Yes, let's dive right in. Introduction to platinum. All right, moving on. Properties of platinum, chemical symbol PTA, atomic number 78. Now, let's talk about its characteristics. Platinum is a dense, malleable, and ductile metal with a silvery white appearance. Its resistance to corrosion and tarnish makes it highly valued for many applications. Next up, let's explore the occurrence of this fascinating metal. Platinum is one of the rarest elements in the Earth's crust. It's often found in alloys with other platinum group metals such as palladium, iridium, and rhodium. Finally, let's discuss the uses of platinum catalysis. Platinum is a core component of catalytic converters in automobiles, where it helps convert toxic gases into less harmful emissions. Jewelry. Its lustrous appearance and hypoallergenic properties make it a popular choice for fine jewelry. And in electronics, it's used in electrical contacts and electrodes due to its conductive properties. Chloroplatinic acid definition and formation. So, what is chloroplatinic acid? Well, its chemical formula is H2PtCl6. It's composed of the hexachloroplatinate, IV ion, where platinum is in the +4 oxidation state coordinated with 6 chloride ions. As for its properties, chloroplatinic acid is a yellow-green hygroscopic solid. It can also exist in solution when platinum is in a dissolved state. Now let's talk about the formation process. Typically, chloroplatinic acid is formed by dissolving platinum in aqua regia, which is a potent mixture of hydrochloric acid, HCl, and nitric acid, HNO3. The dissolution of platinum can be represented by the following simplified reaction. Platinum plus 4 hydrochloric acids plus nitric acid yields H2PCl6, nitric oxide, and 2 water molecules. In this reaction, platinum metal reacts with chloride ions from HCl, and nitric acid serves to oxidize the platinum to its +4 oxidation state. The dissolution process. Let's go through the step-by-step procedure. First, safety precautions are paramount. Before dissolving platinum, it's critical to wear protective clothing, including gloves and goggles, and to work in a well-ventilated area or fume hood. Next, preparing aqua regia involves measuring concentrated hydrochloric acid and concentrated nitric acid in a 3:1 ratio, HCl-HNO3, in a glass container. It's important to add nitric acid to hydrochloric acid slowly to control the exothermic reaction. Then you introduce small pieces of platinum, such as a platinum wire or scrap, into the aqua regia, contained in a glass or ceramic vessel. Observing the reaction, you'll notice bubbling and the formation of a yellow or orange color due to chloroplatinic acid formation. The dissolution may take time depending on the size and purity of the platinum. Scientific and industrial implications. Let's explore the applications of chloroplatinic acid. Firstly, in catalyst preparation, chloroplatinic acid is often converted into platinum catalysts utilized in various chemical reactions involving hydrogenation and carbonylation. Secondly, in electroplating, it provides a means for depositing a thin layer of platinum onto surfaces for enhanced conductivity, aesthetics, and corrosion resistance. Now let's delve into some chemical insights. The process of dissolving platinum in aqua regia emphasizes the principles of oxidation reduction, where platinum is oxidized and nitrogen oxides are generated as byproducts. Additionally, chloroplatinic acid serves as a significant example of coordination complexes in chemistry, showcasing the interaction between metal ions and ligands. Conclusion. Understanding the process of dissolving platinum and forming chloroplatinic acid not only highlights the fascinating attributes of platinum as a noble metal, but also serves as a gateway into advanced topics in coordination chemistry and industrial applications. From catalysis to electroplating, chloroplatinic acid is integral in translating the unique properties of platinum into practical uses, demonstrating how chemistry transforms materials in innovative ways.